I'll get started. So I'm going to be presenting on generative design with a focus on Revit and Dynamo, given this is a Dynamo user group. But I will also show you how you might be able to use Rhino Inside and Galapagos for Grasshopper to undertake a similar study. So I guess, g'day mate, or I know you guys probably say, I think it's Kira Ora over there. So just a little joke, I don't follow the rugby, so I know that a lot of New Zealanders will definitely have that on us as Australians, because I know your rugby is very strong, but I do like Lord of the Rings a lot, so I guess that's one thing we do have in common. But just a little joke to start off. So this is me before COVID came and made me stop looking after my hair for a few months. But I have an architectural background, a master's and a bachelor's, so this is the context I typically present from. Based in Sydney right now, but from Adelaide originally, in the central south of Australia. I've been in the AEC industry for just over 10 years now, and about half of that time I've been spending as a BIM manager. And I've currently actually moved on to my own thing as a BIM consultant, and I specialize typically in the use and implementation of Revit and Dynamo. So my work. So I launched BIM Guru at the start of this year. I formally opened in March, but I was essentially setting it up since early this year, almost late last year. I'm sole trading right now, so it's just me, but I do provide general BIM consulting services, some hands-on, some strategic. I've had about 50 clients so far, so it's been a really interesting year and quite busy, quite dynamic. I also sell Revit content on my website as well and release articles and promotion from time to time, and I just hit 5,000 followers on LinkedIn as well, so it's been a really successful avenue for me so far. So if you are looking for quality Revit families, I do sell my own custom built families. I've got about, I think, 15 content packs on there now, almost 800 families. So it's pretty thorough. But my play, this is probably where a lot of you probably know me from. I started my YouTube channel, the Aussie BIM Guru, in March of 2019. And we've just got past 10,000 subscribers. I typically make BIM tutorial videos, usually about half an hour long, but I'm trying to reduce the length just a little bit because I know that we're all busy people. With a focus on teaching Dynamo and Revit from a practical perspective in the industry. So not only teaching you the basics, but trying to show workflows that we can apply in day-to-day practice and things that I have applied in day-to-day practice as well. And I'm started going on podcasts as well this year. So if you do have a podcast, I'm more than happy to jump on if you think the topics align with what I do. So like I said, the channel's just had a bit of a rebrand. I've just went past 10,000, I think it's 10.2 now. And I've just went over 200 videos as well, but there's a lot more to come in future. Some resources that I've gone and done that sort of overlap with what I'll be showing you today. I do have 3 videos where I focus on generative design for Revit, Rhino, and comparing them, with a focus on the generative design tool for Revit. And I'll be using some of these examples today to contextualize how you might be able to use the tools. And I also released an article recently called Is Generative Design a Problematic Solution? Which will also overlap a little bit with what I'm going to show today, just on my opinion on what it really takes for generative design to succeed, especially in the architectural context. So the running order today, I'm going to talk just about what generative design is first, because a lot of people probably still don't quite understand the concept and what it means, and then really focus on some of the challenges that I see that need to be overcome if you want to succeed at generative design and make it work in your organization. I'll then have a brief demonstration just showing a script that I've already built that just sets up a basic house and shows just how some of the aspects of the tool function in Revit. Then I'll actually show you a script, and I don't know if I'll go through the specific building of the script, but I'll at least go through node by node and explain what each part of this script is doing. I was going to build it, but I think it might take just a little bit too long, but I will focus on at least what inside Dynamo is happening, so you can understand the relationship between the generative study and the Dynamo script. And then I'll briefly show just an alternative approach using Rhino inside Revit. So not just Rhino and Grasshopper, but actually running Rhino inside the Revit engine. And then just a brief Q&A session after that, hopefully. So what is generative design? Well, it's really, simply put, it's generating multiple outcomes for a given scenario or challenge. So taking a problem, finding multiple solutions, and then measuring their success, or what we might call fitness, which we usually measure as a number so that we can really easily compare it to other studies. From there, we can filter, cull, or select the best outcomes from that field of studies that we undertake. So it gives us access to quite a dynamic way of testing both flexible and rigid constraints upon a design challenge. So rigid constraints might be something like the planning volume that a building has to occupy, whereas flexible constraints might be the dimensions of that building within that planning volume. So we could just imagine the most simple generative study possible might be just a box with 2 dimensions. So we'd first establish our constraints that are going to be flexible, in this case a width and a height. We can then say that we have domains that we're going to test between, so an upper and a lower value, and these are going to be like a little slider that the generative tool can flex between, and typically this is how most generative solver tools will work. So in this case we have 2 domains, 1 per variable. From here we need to establish a fitness goal, and this is usually the most important part to a generative study. It's one of the things I recommend that you identify as early as possible. What is the measure of fitness? Because we can't always easily measure something that relates to fitness, given that it usually needs to be a number, especially if you're doing something that has like an aesthetic measurement, like how good does this design look. That's usually going to be hard to measure using a number. But in this case we could say the perimeter or the area, and we could minimize or maximize as a target. From here we can generate any number of random studies or optimized studies, and then this generates a field of results that we can work with. And from here we can filter, cull, select to find the best possible outcomes that our study can possibly generate, and these might lead on to a specific design that we select to explore further. And this is typically at least how I've used generative design to date. So behind the scenes, generative design tools are actually using very complex algorithms, typically ones that we would define as genetic. So examples of these include the NGSA2 algorithm or the Spea algorithm, depending on the solver that you use and the way that you apply it. So one of the stumbling blocks to really complex generative design is it usually involves a pretty deep understanding of mathematics and how algorithms function from a mathematical perspective. So if you were hoping to dive really deep into generative design, but you thought maybe maths was going to finish at high school, probably the first challenge with generative design is that it definitely doesn't. People that are building their own generative tools, such as Testfit, Hyper, Archistar, they're using algorithms that most of them are writing themselves. So an algorithm might look a little bit like this. As you can see, it's a little bit complicated. And remember that this is just a diagram of what's happening behind the scenes. It's even more complex than that. But essentially you can sort of see like a line of culling that we're saying below this line we're filtering out results before we even get to a generation of our generative design study. So this might be what you could call an optimization routine where you're only allowing a certain result through from a sub-study. So it can be quite complex. But I guess the good news is that at the surface level, we just see the tools and the solvers. So Autodesk's algorithm sort of lurks behind the scenes. I believe it's the NGSA2 algorithm, or at least a take on it, but you just see the surface, what happens there. So the good news here is you don't see it. The bad news is if you do actually want to manipulate the algorithm a little bit more, you don't have that deep access into that routine, but I think most of us wouldn't know how to manipulate it anyway. The alternative is Spea. This is used in such tools as Galapagos for Grasshopper. I like to look at it a bit more like an evolutionary process. So you're taking something, and as you leave it for longer or as you run more studies upon it, it gets better or more fitter. Unfortunately, it also means that we're terminating the weaker results, so not every Pokemon makes it. But yeah, like I said, the Galapagos engine for Rhino 3D is essentially using this algorithm, and unlike the Autodesk tool, you're going to see in my demonstration that it actually exposes a lot of the generative aspects of the algorithm to you much more holistically, which I hope is maybe something that Autodesk is looking at doing in future as well. But I guess simply put, it's a little bit like this. In Grasshopper, we call the generative inputs genes, and we feed them through a study or an algorithm that we write ourselves. I should probably point out too, if anyone doesn't know what an algorithm is, it's really just like a set of operations to lead to a result. So when I say an algorithm in Grasshopper, just see it like a script. But we get the goals, and then we analyze those goals and how our study went, and we send back the best results to the input genes. So we're essentially clamping those slider values until we get an optimal or an optimized outcome. So this is sort of how that process of evolution works. But I guess one thing I've noticed with generative design is it has become a little bit of a buzzword or like a hype cycle. We see these pop up quite often in architecture. Probably the one before this was artificial intelligence, which is sort of still doing the rounds, and probably digital twin to some degree as well. But a lot of people are talking about generative design. Some people are playing with it, but I haven't really seen a lot of firms actually contextualizing the use of generative design. There are some, but I do notice that a lot of people are really just experimenting with it, and they haven't quite found that fit for the tool or the workflow with the traditional architectural practice thinking. So it can feel a little bit like that if you're just starting to explore it. So I always say to the walkers that it is time to look at who's actually using these tools and why it's successful, how they've made it successful. Some good examples are NBBJ's digital team. Gensler's got a digital team as well now working on this, or proprietary companies like Testfit, Archistar, Hyper. And typically these companies are using quite advanced versions of generative studies. Some of them use Rhino and Grasshopper. Some of them use their own algorithms. But the one thing they all have in common is they're not using Revit or Dynamo. So it's sort of food for thought on, I guess, where the destination might be for this movement. Here's an example of just at least the dashboards that NBBJ sets up, but I do know some of these have some generative capabilities built in to optimize and test various options upon sites. And there's other tools they've developed that are different to this as well. But one thing they have done is really cleanly packaged the experience for the user. This does take quite a lot of time to set up. So when people see these really clean dashboards, they do need to understand that I guess there's a lot of time and effort invested in not only building the script, but also the experience as well. Gensler, for example, they don't share as much on what they do, but I do know they are using generative and solving-based routines for doing things such as chair distributions in their offices to find the optimal maximum seating arrangements based on COVID separation, which is actually what a lot of people are probably using generative design for right now. And such companies as Testfit are using what you could probably call generative design. At the very least, it's algorithmic design to find optimal layouts upon sites, and which leads to rapid prototyping tools such as Testfit, which enable people to bypass a lot of the manual or design processes that usually would take a lot of time during feasibility or master planning stages. So it's important to understand that generative design isn't new by any means. Generative design itself has been through a few different stages of development with Autodesk. Probably the latest one people knew about was Project Refinery in the beta phase, and it did have a few iterations before that again. What we have now is similar to Project Refinery. There are a few small changes that at least you can see at the surface level, but for the most part it's been a fairly consistent tool, at least for the last couple of versions. So generative design itself came to Revit 2021 near the end of last year, but it's important to note that Rhino 3D has had these types of tools available for almost 10 years, which really leads me and probably anyone else to ask the question that if we haven't embraced this, as a firm, as a person, as an industry, will it change just because Revit got a new tool? I'd say in a lot of cases probably not, but at the same time it does lend the question that maybe there are some things that might make us consider it. So like I said, the big question is, if we weren't using it then, why would we use it now? Well, some answers that are good are that obviously our computers are stronger. We can run more studies more quickly on more computers with more memory, more software that can support it. We're also learning how to code in AEC now, so such programs as Dynamo have exposed more people to a computational way of thinking, which is really required in generative design. As well as this, our projects are becoming more complex. So there are more complex things we're measuring, things we're creating, things we're analyzing. So this could be a way to solve some of that complexity that analog processes can't really take on. As well as this, a lot of our clients are becoming more data-centric, or we're taking on more clients that already happen to think from a data-centric perspective. For example, I can see companies like Tesla starting to move into the architectural industry, at least from the production of their own factories. They have in-house BIM managers now that I know of. So it's interesting to see that the programming sides of all the industries out there are starting to coalesce a little bit more. Some bad answers for why generative design might be something you're considering. Typically the worst one is that it can do our job for us. I find that this is also, it's a good reason not to do generative design, but it's also one of the biggest arguments people use against it, saying that I don't want the computer to do my design for me. So it's a wrong way of looking at it in both of those aspects. So the idea of press button make design. It's not really the point of generative design. It's really more of an analysis tool to help us make better informed decisions using studies and scripts that we design ourselves. Another thing people say is we can save money. One thing I'm going to show you through all this is that generative design is complex, and it's also quite timely, so you may not actually save money, at least in the short run or directly. It might be a passive benefit to your project that returns time or some other metric that can sort of lead to money. As well as just the idea that we can sort of wow our clients with something they don't understand is probably something that we saw challenges with BIM itself, in that we have BIM wash, when we essentially say we're doing BIM when maybe we're not, or we do BIM, but our clients don't really know what they're paying for. So we need to make sure generative design is something that's at least managed in a way that relates back to what our client actually needs or actually understands, I think. But I guess if you see those good answers and they are actually drivers for generative design, then don't let what I say sway you away from it. Definitely explore it. Definitely put forward business cases in your company to see if it works. But if the bad answers are the drivers, the generative design might not be the right solution. So one of the challenges with generative design, which is probably quite obvious, is that it relies really heavily on programming or coding. So in Revit, it relies on Dynamo, and in Rhino, it relies on Grasshopper. And beyond that, you're using complex algorithms, so it's pretty advanced if you're already using BIM. This is another step beyond that again. So this is an example of a simple study in Dynamo. So unless you're a really experienced Dynamo user, I'd say most people wouldn't say that looks very simple. But in terms of what this study can achieve, it is quite simple. This is actually the script for the house that I'm going to show you quite shortly. And this took about 3 hours to put together, so it's not always the easiest thing to approach from the start. Generative design also usually relies on geometry, and as a result, mathematics that relates to geometry. So I find that designers really do need to have a great understanding of the fundamental Euclidean or underpinning aspects of the shapes that they're using, because you are essentially going to have to code them and measure them and determine how much surface area they might have, for example. And whilst coding tools do have certain shortcuts in some cases, you will from time to time need to use some pretty abstract or advanced mathematics, whether you're generating something like a sine wave or whether you're generating something that relies on circular trigonometry. There's a lot of complex aspects you can run into quite quickly when you start looking at a generative study. As well as this, generative design isn't very good at lying to us. It's pretty honest. So I do find sometimes some companies will undertake a generative study and they don't get the result that maybe the design director wanted it to give them. So I find if you're approaching generative design with an idea of what it should be telling you back, it's not always the best workflow, because you might sort of get caught with your pants down if you're not careful. As well as this, studies are very specific. They're undertaken with the various sets of parameters or inputs and various goals that you measure. So these aren't always easy to take from project to project because they're so heavily defined. So if design directors, for example, make a really small change at the last minute, like changing something that's circular to a box, I mean, it might seem like a small change from a modeling perspective, but from a computational perspective, it's not so small. So you do need to consider that there is a degree of understanding that the design team will have of what actually takes a long time to manipulate. And maybe generative design might just become like a really small portion of a bigger workflow for how you resolve your design process. And I guess, as you've heard me say a few times now, building these studies does take quite a lot of time. That study I showed you before was about 3 hours to put together in code. So I think a lot of generative design studies will begin and end as rejected business cases. So it can be a pretty challenging side of the industry to tackle. I know some people personally through my YouTube and my LinkedIn comments that have been trying to justify this in their companies, and it's quite hard because the time investment is hard, especially when you're trying to sell it to people that don't understand that the process or even the result that it's going to achieve. And I guess generative studies typically will begin with questions, not necessarily answers. So it is a bit of a linear process, so it can take quite an abstract way of approaching a problem to get the answer that you wanted. Sometimes undertaking a study really focuses a lot more on what makes a design successful. So like I said, if you're targeting aesthetics, like is this design beautiful, generative design probably won't really be able to measure that for us until something like artificial intelligence can actually validate what makes images attractive. For now, it's more about measuring metrics. So optimizing surface areas or sun shading angles, for example. On the right here, you can see an example undertaken in an article by engineering.com, which I like to reference, where they optimized the Golden Gate Bridge in Fusion 360. And I think most of us would agree it's not the most attractive outcome, but in terms of being efficient and structurally sound, it was, I guess, a good outcome according to the software. So you can imagine sometimes you might get an outcome that probably isn't going to actually become the final design, but maybe what you get out of it is the true value of how that study's undertaken. As well as this, there's a lot of proprietary tools being developed on the side to the platforms we typically use in AEC. So if you're not all in on developing your own scripts and programs, I would suggest that you either wait or you pay a little bit more attention to some of these platforms that are being developed on the side, such as Testfit, Archistar, Hyper, etc. There's quite a lot of them out there right now, and I think that a lot of them are really getting quite realistically close to impacting either our market or impacting the development market, which will in turn sort of come back to us. So the first example I was going to show you is just going to show you a script, how it's moved into the Generative Design tool and what it does. So in this case, I actually took a very basic house layout, just a single story house. I more or less treated it like a fixed layout, except for a couple of rooms that I made optional. And then I'm basically targeting any area from an optimization perspective. And I'm giving all these rooms just a little bit of wiggle room in how much area they can occupy. So I'll just jump over to Revit and just show you at least the study itself. So it's not actually going to be in this model. This study is built entirely in Dynamo, which actually a lot of generative studies probably are, because you're typically having to program your geometry rather than take it out of the Revit model, which is quite a big challenge because some people are used to taking inputs from Dynamo, from Revit into Dynamo, and then working with those. But in this case, I've actually programmed every single piece of geometry as its own little piece. So I'm not going to break down everything in the script, but essentially I've got a whole bunch of inputs. For example, the dimensions of my site. I'm doing a lot of processing to essentially start building forms, such as the boundary of my site, and then taking various pieces and progressively building other components of the study. So for example, defining my alfresco or my garage or my corridor. And there's some inputs here, like, is the alfresco included? In this case, I've been setting these all to inputs for the generative tool. I've also been setting ranges for some of these elements. So for example, the bedrooms can't be shallower than 2.4 meters and they can't be deeper than 3.5. And then set certain steps of how far along that range they can be. These are going to be the inputs that the generative tool can flex in order to create my study. I'm doing a fair bit of just basic geometry processing, a couple of optional logic gates to process whether some of the rooms are included or not, and then sort of collecting some metrics at the end. So right at the end, I'm essentially collecting these elements as surfaces and measuring their area, and then I can target these as areas right at the end. So I can target the area of my living room, my corridor, my lawn at the front or the rear, so I could minimize my corridor and maximize my living room, for example. But obviously I'm dealing with quite a fixed layout here. So from a generative aspect, it's already a little bit limited in how I've approached the problem. But to create like a space planned flexible element, that would take a very long time. That's a whole nother side of the generative design study tool again. It relies on a package called, I think it's called space planning, just word for word. And it involves a very abstract way of approaching a design. So you're not necessarily generating a floor plan, you're generating a space matrix with relationships instead. Sort of like a functional relationship diagram, which you might have seen before. So at the moment, this Dynamo script is just generating one outcome based on all the inputs that I've given it. But what I've done after this, went to Generative Design, exported for Generative Design, and then I've exported this out into Revit as a study, given it a name, given it a logo. And in this case, I don't have to cache any data into my script because it's going to be running with fresh data every time. There's no Revit data that it's collecting. The study that I'll show you after this one will collect a few Revit elements, so it is still possible. Sorry, I've just got a cat about to walk across my computer. There we go. So in this case, I'm actually just going to close Dynamo. I'm going to go into the Create Study button on the Manage tab, and I'm just going to run a generative study. Remember, this isn't relying on Revit at all. It's just all built internally in Dynamo. There we go. So you should get a little tab like this when you run a study. There'll be some default samples by Autodesk, I'd say that the nature of these studies is a good demonstration of some of the limits of the tool itself, especially when it comes to the ability to process geometry quickly. These studies are all quite small scale and quite simple, so they do sort of convey that maybe the tool's not necessarily the right approach if you're doing, say, solar optimization on a facade. In that case, I'd say Ladybug and Grasshopper are probably a better solution. But anyway, we're going to run this generative house script, which I exported earlier, and you essentially get the ability to choose which variables are going to be flexed or measured during the study. In this case, I'm just going to change my method just to randomize. So there's 3 approaches to generative studies. I've never used it like this. I assume that just runs it exactly as the inputs say. Randomize will literally let those values be all over the place. And optimizing will use a deeper algorithm with the NGSA2 approach, and it will actually optimize some of those variables to give you more refined results that are closer to your fitness you're targeting. And then cross-product, I believe, gives you every possible result the tool can create, which in this case would be millions, so I'm not going to run that. I'm just going to work with a randomized approach for now. For now, I'm just going to disable a couple of these variables. So I'm just going to say that my site is a fixed size, and you notice once you disable these, you can specify the input. So you sort of get a bit like a hybrid between Dynamo Player and this tool, which is quite friendly. I believe I might just let the site controls all be locked in this case, just so I have a fixed site condition, because this is sort of how the tool's intended to be used, in that you probably already have a site you're bringing this tool to, and you're just trying to run an optimization of that design upon the site. But I think from here, I'm just going to let every other variable have control. So these are all the dimensions of the rooms in the house, and also whether some of these rooms are included. And in this case, I'll just be able to measure my results at the end. So I'll just generate, say, 50. And you do have a seed of randomization, so if you want to repeat the same study, it is possible. But if you want a different result, then you'd want to use a different seed. So once I hit generate, it takes me to the tool itself. And in this case, you can see various studies. In this case, I'm just running Generative House 001. So if you do a lot of studies, it is possible to go through them. And this is essentially our field of results, and then all the variables that those results contain. So it's a little bit hectic in this case because I have quite a lot of variables that I'm measuring, but really the main ones I'm dealing with are these ones that I've just labeled with goal on the front. I usually recommend labeling your parameters to make it easier to tell what your goals are. That way when you see them in this sort of cramped environment, it's not too hard to make them out. In this case, I'll just sort by the area of the living room, and I'll sort descending so that we get first the results that have the largest living room space, and we can see things that sort of make sense in this case. There's a room here I can exclude, and also another room here that I can exclude in Dynamo. And as you'd expect, most of the results that have this don't have the most area when they emit these rooms. But I can see that there are actually some more surprising results. For example, this one here still has a larger living room space. So if I was targeting a design that has an alfresco but has the most living room possible based on other room dimensions, this tool might have been quite useful for me just then, because I would have had to experiment with quite a few setouts. Obviously, again, it's a very simple house, so maybe you're smart enough as a home designer to not need a tool to tell you this. But in this case, you can see that it's not always a predictable result. Like I said, you shouldn't go in necessarily expecting to see the result, rather the tool shows you the result. I can also filter down as well, so if I just want to see rooms that have, or results that have quite a high living area, I can actually just click and drag a little filter and start scrolling down through my results. And you can see that the options field decreases or increases in what it shows you based on this, which is quite cool. So I find it's a really friendly environment and user interface. This is probably one of my favorite things, or one of my biggest positives that I give the tool, in that I think this is a really well put together user interface, especially for people that don't necessarily understand computation. So if you're using this tool, building a script, putting it in the tool, and letting a design director run this tool, I feel like they'd be much more capable of doing this than, say, running Grasshopper or Dynamo itself. So that is one really big positive. And sometimes you will find things that maybe were a bit surprising about your result. For example, we always have the same size lawn here. Well, actually that makes sense because we limited our site volume. But it might also just visually help you troubleshoot when you've set up your Dynamo script incorrectly as well. So that's just a very basic example of what we can do. We can obviously see the numbers that we're using to generate our inputs as well if you wanted to reproduce the study in Dynamo. And if your script does have any creation nodes at the end to create Revit elements, say the walls of the house, this is possible to set up as well. In this case, I've just set it up to run in the tool. So that's just one example of what I would say is quite a basic study in the generative tool. And that's what we sort of went through there. So demonstration 2, which I was going to put together node by node, but I think I'll probably just run through the script instead in a little bit more detail, which is also in the sample files, is dealing with a site solver. And this is probably a much more common application for generative design when we're dealing with a building mass on a specific site, and we want to optimize various aspects of that building. Usually targeting probably the highest yield of area is a very common thing, but maybe we're doing it considering other aspects of the site, such as solar amenity, or also impact on daylight or view analysis. In this case, I'm analyzing my view aspects to find the position on the site where I get the best view aspect, and also the building shape that will give that. There are some things that are probably quite obvious before I even start this study, that the taller my building, the better the views will probably be, because I'll have more opportunities for views. So you might want to mix and match with other types of things, such as maybe dividing the floor plate using a very simple division algorithm to determine how many apartments you can get on each floor, and maybe you'll have a threshold where you need no less than, say, 6 on a floor. There might be some limit that sort of limits what you can actually accept as a good result. In this case, I've worked quite simply and just focused on giving the building a fair amount of free rein and giving it a position on the site randomly, and then measuring the amount of views I can achieve. So I'm going to jump into Revit 2021, and I'm just going to open up the sample Revit project on the sample files and boot up Dynamo, and I'll just run through the script, which is also available in the sample files as well, but I'll spend a little bit more attention on some of the nodes and what they're actually doing in Dynamo as well. So I'll just jump into Revit. Note that if you did have the generative tool open, I believe usually you have to close this. I don't think Dynamo and the generative tool usually let each other stay open at the same time. And I'm just going to open up, I believe I might have to just open it up from here. So I'll just open up my copy. And it should run in automatic mode, I believe. Yep, so you'll probably see a result come through if it worked on your side. The only custom package I believe I'm using here is the Generative Design package that comes with Revit and also with Dynamo as a result. So in this case, I'm essentially starting my script with an input. In this case, I'm selecting my property line from the Revit model, just using a select model elements node, and I'm obtaining its geometry as a polycurve. And at that point, I'm just remembering that input so that I can return this element back to my generative study if I want to just work with this property element from the generative tool, regardless of the model that I'm in. And I'm also just generating a custom preview as well, so that I can see this in my actual output for the generative tool. So in this case, I'm just making it red. I'm then offsetting my site boundary. So I'm offsetting it inwards because I can't have a building that overhangs the edge of my site. So I'm overhanging it inwards by half of the width, which is also the depth of the building. It's always a square building in this case. And this makes sure that, I guess at the very worst, it can sit hard up against the site, which obviously is going to impact on the views. So you probably won't see too many results where it's hard against the edge of the site. I'm then just generating a patch in this case. So I've turned off the preview for some of these, but I'm just generating a surface of which I can place my building within. So I'm placing a point at parameter. So I've got two variables between 0 and 1 for the U and the V of where the building will be placed on the domain of that surface as a placement point. And then from there, I believe at this point, I'm just generating a plane at that point. If I go back a little bit, this is where I'm just targeting the size of my building. So I've been given it a domain of 15 to 50 meters. That's where I feed in that negative offset to move the site inwards for the placement point. I'm then just converting this, and I'm using just a little formula to target a maximum possible area yield that can be achieved as a result of the study. So I'm saying in this case that I can't go higher than a certain number. And this limits the height of my building through controlling the relationship between the height and the width. Because then I'm outputting a height based on the algorithm. I'm then outputting the height. I'm just using a floor to round it down. And then I'm outputting this as a testing target if we so want to optimize it. From there, I'm also creating a range. In this case, I'm creating the number of possible intervals at a 3.5 meter interval that I can fit on the site. So at every floor, I'm going to generate test points to test the view aspect of each level, and then use these to intersect my site. But first, in this case, I believe I'm taking my building, So I'm creating an extrusion and then just overriding that here, just so I can see a preview of my building. In this case, I'm taking this range and I'm offsetting a point at the placement point of the building by each floor so that I have a point at every level of the building. So if I just go and turn off the preview for the building, I essentially just have a stack of points, one per floor. And these will be the points that I place my test lines to intersect with my site. I'm then creating a line outwards in each direction. In this case, I'm using a few things to do this. So I'm firstly creating a vector and rotating it by a range of 10 degrees between 0 and 360, and creating a line, or a vector in this case, for each of those lines. I'm then using a cross product so that for every vector, every point will shoot a line out by that vector, which leads to my test curves. From there, I'm taking those curves and I'm just checking if they intersect with the geometry of my context. In this case, my context is just a in-place mass. One challenge with Revit and site feasibility is that typically the high-resolution city models that we tend to use don't tend to play very nicely with Dynamo. Typically, it will just fail to build most of these because there's too many faces or too many edges. That's where things like Rhino and Grasshopper can be a little bit more beneficial. But in this case, what most companies I know do is they rebuild the site in a more rough representation to the point where it can still be relied on with some degree of certainty for shadowing or obstruction, but at the same time light poly enough that Dynamo can handle it. So in this case, that's what I've done here. I'm taking the geometry and just joining it all together into one solid. I'm then again remembering this form. So this is part of the Generative Design package. And I'm just giving this a preview as well so I can see my site. I'm intersecting all these lines that I've generated, and then just counting, in this case, how many instances of false there are, and multiplying this to generate the number of successful outcomes from the study. So in this case, that's just a really easy way of taking the total number of hits with the site and excluding them from the study, and just taking the successful ones. So essentially, when you get an instance of false, it means that the view rate hasn't intersected with the building volume. And then counting these and scoring this as a yield of the views. So that's essentially how the script works. It's relatively simple. I've also rebuilt it in Grasshopper, so I'll probably show that shortly as well. But once we're happy with the study, I'll just go back and fix some of those previews up. So I'll just turn off that geometry node. If I go to Generative Design, I can export for Generative Design. Again, I can give it a description. In this case, I might just make it again. So I'll just say site optimization 2. And this should create a copy of the Generative Design files. Typically, they get stored as a little subfolder in your documents. I believe there might be a way to change that path in your preferences, but typically that's where I just let it save to. So I'm just going to close Dynamo. At this point, it's important to note the script and the tool have no relation, so you do need to re-export if you want to update your script. So I'm just going to go back to Manage, Create Study, and we should see a new study available. So you can see in this case, I've just got this second site optimization. I can then, in this case, maybe work with an optimize function so that we see slightly less variance in our results. And in this case, I'll just let UV and the width factor of the building just be flexible. Let's say we're trying to just we'll try minimizing our height but maximizing our score. I haven't tried mixing these two before. They could be quite interesting. And you can also set thresholds for the constraints of what you'll accept in this case as well. Let's just work with a population of 20 with 10 sub-studies in this case. So when I generate, it should open up the tool again, and we should now see some results starting to be generated. In this case, we're doing 10 sub-studies with 20 internal generations from an optimization perspective using that algorithm. So it will take just a little bit longer, but there we go. We can see we've got quite a high variance of results. So we may wish to pump up the number of results that we are measuring. But again, in this case, I can check what's my highest height. I can see I get some relatively, probably what you might say are silly results. So this tool is good for showing you when you've been a little bit too generous on certain constraints. But I can also see the worst results are obviously the shorter buildings. And it seems like there's not really an aspect that's best on the site, at least at the moment from what I can see. It looks like some results are preferring this corner. of the site, but it's probably not quite enough for me to make any good judgments about the study yet. So what I like to do sometimes is just do a randomization study with a lot of results, because I found randomize is quite a quick study to do. So sometimes I'll just do randomize, and I might do something like 150 results. So it can be relatively quick at generating results, depending on the complexity of your study and also the fidelity of the geometry that you're using for testing. That really does have quite a big impact on the results. So I can just start sorting descending already, and obviously I can start to see that there's a bit of a trend with my results, at least that obviously the really tall designs are giving a better yield. And I can start to make some assumptions at least about maybe various aspects of the site that seem to be performing better. For example, I can see this back corner of the site is sometimes preferred and sometimes this front corner is preferred as well. Now, one thing you can't do is obviously go and view those preview geometries. So let's say I want to go and see all those sight lines. I'd have to make that a part of the study. So there is a little bit of interactability lost to some degree. You can at least navigate the preview, so you can move around this result, which can help. And I can obviously go and sort of clamp certain aspects and say, okay, I only want to see my really successful results, and I also want to see my unsuccessful results. Now, one comment I got on this video that made me think about just having to think in a generative way was, well, what if I just want to test one outcome? And I'm like, well, then you're not even using generative design. So it is good to think about whether you're letting the tool do the talking or whether you're talking to the tool, in which case you might just need a Dynamo script to prove your idea. I might just also quickly show you the same thing, but using a Rhino Inside approach instead, because I think that's worthwhile for comparison. So we're going to be using the exact same challenge, but I'm going to be using Galapagos as my solver instead. And Rhino actually has a lot of different solvers. I think it has more than 10 that are quite well known, and some of them are very complex as well, far more complex than Autodesk's forays. But in this case, I'm just going to boot up Rhino Inside. I'm just going to open Rhino inside Revit, and this is my Grasshopper script built to essentially achieve the same outcome. So I'm actually sourcing live Revit elements at the moment. So this is actually a select Revit element node in Grasshopper. So if you've used Grasshopper and you haven't used Rhino Inside and you use Revit, definitely check it out. It's pretty cool. Probably don't have enough time to really go through it all. This is my gene pool in Galapagos, which allows me to set my variables. And I can also just shuffle the gene pool if I just want to quickly test one result. You can see the impact of that on my study here. But what I'm doing is essentially taking all my results through right to the end, and I'm collecting a numerical fitness measure. In this case, this is just the number of successful views. I can then work with the Galapagos solver itself just by double clicking at the end. And this is Galapagos itself. And you can see that you have quite a lot of control over the tuning of the study. You can also tell it, say how many results you want to send through to the next iteration to let it evolve. The solver itself is quite complex. I'll need to actually start running the study to show you the solver. But one thing I do want to point out is the speed of solving is quite rapid, and you will see pretty much every result as it is solved, which is pretty cool. So I'm just going to start solving, and you'll see that the field will start populating itself and telling me, I guess, it's getting more optimized as it goes. So I can start to look at certain portions of the gene pool and start looking at only the most successful results. And unlike what we did before, we can start to make some informed assumptions about what we're seeing. Because it's evolving, it's obviously showing us one portion of the site which has yielded a really good result. Now, this might just be a coincidence. And in this case, I could typically just go back, stop the solver, shuffle my gene pool, and just start again, just to make sure that we're not making too much of an assumption. But there is some degree of sort of human interpretation of what's being shown to us. So you do have to be careful with evolutionary solvers that there might be multiple optimal outcomes for your study, and you might just be happening to miss one of them. We can see again, we're getting a pretty similar result, but I find sometimes with this particular study, actually no good, it did find a different result. So sometimes it does seem to find this portion of the site instead. So unlike the Autodesk tool, this is a much more specific outcome, but there are much more interesting ways we can interact with those results. And an evolutionary solver can also take a successful gene from a previous study, reinstate it as the current gene pool, and just begin from that point. Now in this case, we've just let it be purely random again, so it's not necessarily working on a pure evolutionary perspective, but you can see it found that result much faster. So it is a good way to at least verify that there isn't like some abnormalities around that area that we just happen to make too many assumptions about. So it's pretty interesting, and I definitely recommend checking it out as well, especially if you've already tried the Autodesk Generative Design tool. I'd say try Autodesk's first, because you may find that you might find yourself a little bit biased just because of the speed. But I think there are some really good things about the Autodesk tool as well. So there's a few options you can use. But I guess in conclusion to what I've shown you today, I guess I just want to reinforce that we shouldn't be afraid of experimenting with new methods. If we don't, someone else will. There are a lot of disruptors in our industry, and I do think there is potential in generative design. Having said that, I do know that some of my presentation is a little bit cynical, or just trying to be ultra realistic. Ultimately, I just want to see this be handled openly and honestly by the industry, as well as a lot of the software vendors who I feel maybe aren't always honest in their marketing about how difficult this can be to implement. Obviously, the difficulty is rewarded through the results you get, as long as you put in the research first. But I want to avoid us having gen wash, I guess, another form of BIM wash. I guess ultimately just be ready to invest a lot of time, effort and money, and to make sure that you ask the right questions about the study before you undertake it, to make sure that the result gives you the most return on your investment and time invested. And also just be ready to use Dynamo, because it's pretty important to these tools. But thanks for watching, and I hope this was informative and gave you some ideas about how you might be able to use the tools. And I look forward to taking on any questions you might have as well.
Gavin, thank you very much for this presentation. I think that it was a roller coaster, honestly.
Yeah.
A very honest presentation and very informative.
Thank you.
Very interesting.
Yeah, thank you. I'm glad you liked it.
Yeah, a lot of from basics to some very important insights and very interesting insights. We have a question regarding Dynamo and Revit, saying, can you demonstrate, create Revit elements? I think that this question is related to when you select or you want to actually create elements from the generative design solution that you select.
Yeah, so I'll see if I can just quickly generate maybe a quick study from the basic sample project. I believe that might support one of the studies quite quickly, because I guess my studies haven't really been built to generate elements. That's one of the challenges, but I'll just try opening up a sample project. I believe one of them should work in the basic sample project. I might just need to hijack the path from my 2020. But yeah, just bear with me, I'll open it up. But I guess in the meantime, yeah, it ultimately just depends on how your script is configured. I might be able to actually access the Autodesk script in this case, just to have a look at how that looks. Just bear with me, just trying to find my studies. So I think by default, I should be able to find one of the scripts that Autodesk has set up. I think the maximize window view dependency might create something right at the end. So I'll just need to open Dynamo. I'll just get a path to one of the sample projects first. I've got it somewhere in here. Here we go. So I think I'll just use the basic sample house, and I'll just upgrade it. Haven't really been using Revit 21 too much yet, so still laying out all my shortcuts for that one. Mostly working in 2020, but I'll just upgrade this anyway. But I think this script, it's built to optimize the placement of an object based on all the windows in a room. So it essentially just generates from a point a cone of vision to each window, and I think it checks all the obstructing elements that you can tell it. So if there's chairs in the way, it's a bit of a strange study. Like, I don't know if it's that practical, but I'll just see if I can look at the actual Dynamo behind the scenes as well. It might be locked off depending on how Autodesk has set this up. It looks like in this case, no, it's been condensed as a JSON. I'll just try it looking at the study anyway. So I believe this one lets you generate the elements at the end. So I'll create a study. And if I use the maximize, I could use the workspace layout one, but I'll try this one. So if I remember right, this one enables you to select a few things. So we can calculate the view from an element. So in this case, I'll just say I'm sitting on this little chair. We can select multiple windows as well. So I believe in this case, I should be able to pick a few window elements. And this is actually using a pretty cool tool from the Generative Design package, which is a filtered selection, which is pretty handy. So it limits how many types of categories you can pick, which is pretty hard with the previous versions of Dynamo, where you have to select any model element you can select. So I find this is a really handy node just in general. We'll select the room that we're undertaking the study in, and we'll just pick some obstructing elements as well. And I believe it should just generate an obstruction on the floor plan, even if it's not tall enough to obstruct. And I'll just generate 5 solutions. And it should generate at least the preview geometry for the study, I believe. Here we go. And I believe this one should support the creation of Revit elements. Okay, so it doesn't show us the preview, but I believe it might create an element. Hopefully. Element creation completed. Not quite sure. Oh, there we go. It's created the chair here. So I guess that's the point that at least we tested from. In this case, the element creation probably isn't like a very logical outcome, because I guess it's like the point that we essentially tested from. But I guess this is where you could tell your script to send some points to at the end for that creation node. I believe you need a gate in Dynamo. I think that's the trigger for what stops it from creating until the very end. So in this case, or it might just not create elements by default, but I think there's a gate node. Yeah, so there's a gate node, and I believe that's what triggers the creation limitation. But I haven't actually done too many scripts that generate elements, so I might be mistaken here. But yeah, I'd at least experiment with this node and just an element creation on the back end of your script, such as just to create wall or something like that. And I think that's at least how that process is intended to work. So you don't create the element until you nominate the study that you're happy with. And that's the point where you can send the final creation of those elements back to the actual Revit model itself. Typically, I find that sometimes you can just literally take cues from what the study told you instead of creating an element as a result of the study. So for example, with that generative house layout, in that case, maybe creating a house isn't the best output for that script. It just depends on how you need your script to work. So I think it's probably just worth experimenting with those gate nodes, and I'll probably put something on my channel maybe at a later date just showing how a more meaningful script could generate elements instead. You might be able to use the workspace layout script. I think is probably maybe more meaningful. So I think there's a study in here that can do that. I don't think the desk is in here that does the actual placement of the script. I'll just make sure it's actually here, because I know there's a specific family that does the final step. Desk, I don't think the desk is here. I'll just load this in. I only just noticed the new Autodesk content tools come in as well, which is pretty cool. Looks like my content library is a little bit limited. Interesting. That's strange. I had content there before. Not sure where that went. Yeah, strange. It looks like my content library's been replaced by the last update, which is a bit frustrating. Yeah, I probably won't be able to do it in that case because I don't have the desk I need. But definitely just try out the desk layout tool as well, and that will hopefully generate the desks on the back end of that script as well. But yeah, sorry I couldn't show you a specific example that I had on hand. I'll put something on my channel probably early November, hopefully, to cover that one. Yeah.
Thank you very much. We do have another question regarding where is the filtered select element node found?
I'll just open Dynamo. I think it used to be in the Generative Design package. I think I could see it there before. Yeah. I think it's under selection. And in this case, there's like limited selection options such as select room or select wall. Or in this case, you can only pick like say family instances. So there isn't like an explicit category driven filter yet. I do know that you can do this using the Revit API. So I know, for example, John Pearson of Parallax has built his own plugin that does this. I don't know if he's selling it yet, but I know that it involves, I think there's a selection filter. I think that's the name of the element you have to use in the API. But they've at least built a few, I guess a few simple ones.
Using API is definitely possible.
Yeah, so I think it's relatively straightforward if you know how to use C#, but I guess if you don't, it's probably a little bit trickier. But I guess in the meantime, there's a couple of common types that you might need here, and even some drag selection options as well. So different types of selection boxes versus explicit selection. Yeah, but that's where you can find them for now.
There's also another question regarding, it is a general one, regarding the architects and designers with more than 20 years experience.
Yep.
And if I get it right, the question, it's more a comment related to the process. So this is somehow helpful to understand, and it's an addition to the design process and mindset somehow.
Yeah, definitely. I mean, generative design's been a good way to sort of expose at a more present level in the industry how computational thinking really has to operate to support a meaningful outcome. And even this presentation I showed today probably wasn't as focused on Dynamo itself, but more about giving some honest advice to people that may be trying to set up generative design in their company. So I know this is probably the next barrier that most people are experiencing with the tool, not necessarily how does the tool work, it's more about how can I justify return on investment to my directors or actually generate meaningful outcomes for the clients. So yeah, I totally agree that, you know, it's more about the way of thinking that this is more supporting rather than using Dynamo itself. Obviously Dynamo is still necessary to generate the result, but that the thought process is much more intrinsic. And I think it does mean that yes, those 20 plus non-technical users still have a very relevant place in this type of design process, because they can still think about design constraints and how they might measure the success of the design. And obviously they bring a lot of realistic construction limitation to what a building can even do. So sometimes you might see an outcome and someone might go that cantilever is not possible. So you can sometimes marry those two schools of thought together in this process. Yeah.
I think that I just want to highlight some points that I found inspirational, I would say, in your presentation, and very fit for our discussion. The first one is that generative design is about the right questions.
Yes.
So this is the first point that we all need to remember when approaching generative design. The second one is that generative design, it is a multidisciplinary effort.
Yes.
Involving design principles, math, geometry, programming. And the third one is that generative design is also a creative approach to define a path, basically a strategy to go from start, that is the questions that we talked about, to the end, so the possible solutions.
Yep.
So it's not just a technical effort, it's a creative effort as well. A couple of personal points. The value of some solutions is also to break barriers, like you said, so enabling users to then explore other solutions. So the value of Dynamo in this context, my opinion is that is very useful to somehow get in touch with the principles, the philosophy somehow, and then to explore more complex solutions like you said, Grasshopper, or based on Rhino, or even through classic programming. Why not?
Definitely.
And you pointed out a few times about the computational limitations of Revit and Dynamo, and this is an important point.
Yep.
And most of those are related to Revit using a single processor for most processes. So that's somehow a technological limitation that, in my opinion, is somehow limiting the application of Revit and Dynamo to very complex studies.
It's also just based on the Autodesk shape modeling portion of the way it's been set up as well. I know there are some different ways that things are generated versus other geometry engines like Rhino 3D. Like Rhino's obviously dedicated for almost purely for geometry's sake, whereas Revit's a BIM platform, so there's different considerations that both programs are having to apply to the geometry creation processes, how they both deal with NURBS, for example. So there are some challenges there, and I think it was great you mentioned that. I guess that it makes us think more about the constraints in our projects. I mean, most of what I know about feasibility and site limitations wasn't through actually working on projects with those constraints. It was through research after knowing generative design actually relied on these quite heavily, and I said, well, I need to actually learn these numbers now so I can actually build a script that has the right metrics, because it's easier for someone that can put these numbers into Dynamo rather than having someone over your shoulder doing it all with you. So it was a good way to sort of expose users to that side of the design process as well, I think, especially when you have things like Ladybug becoming more important as well for environmental analysis, and some of those design constraints are more obvious now to people that didn't think about them as much before. Yeah, but I can see a few people saying thanks. Someone said it was quite fast, so hopefully the recording might be a bit easier to follow. I think if you watch it on YouTube, you can actually set the speed to 75%, which makes me a little bit easier to understand sometimes. Yeah, but otherwise I think we're all good. But I'd like to thank you for having me on board. It was a lot of fun, sort of sharing my thoughts, and congratulations on the 200 members as well. That's a really good thing for a user group to hit. That's a quite a large member count. So look forward to seeing the sessions when we're back in the office and see all those faces. Yeah.
Yeah, we are a small community, but we are growing. Also taking inspiration from you and other people on LinkedIn, on YouTube, and we want really to thank you not just for this session that was honestly very, very inspiring, and but also for all the work that you are doing in online. And this is something that I think we need to thank you, and again all the other people around the globe fueling the through or sharing our research. Independent research.
Exposing it. Yeah, no, thank you. It's been a really fun journey, sort of undertaking this Aussie BIM Guru thing, and it's been great to sort of meet people around the world. And I definitely encourage anyone watching that has a passion for sharing knowledge to either start a YouTube channel, jump on LinkedIn, find your medium, and start sharing where you can. Obviously, don't go exposing all your company's workflows because you're probably not allowed to do that. But where you can, share what you can, and we'll see our industry improve by the day, hopefully. Yeah.
I want also to encourage the young generation connected to this webinar to also to have a look at Gavin profile to understand how a profession in the BIM environment can evolve, and because he made a very interesting path, and I think he's just at the beginning. So have a look, get in touch with Gavin on LinkedIn, because he's a very he's a guru. Okay.
Oh, thank you. Yeah, no, definitely reach out. I'm trying to be very available for the industry, and if there's any graduates specifically watching this, there's a presentation on my channel called "Getting Started with BIM for AEC Graduates." I actually presented it to Nigeria, but it's probably quite relevant to Western markets as well. So definitely check it out. Yeah, cool. But otherwise, thanks for having me on board, and look forward to seeing future sessions.